And we will have Anita get started talking about this week's additional information support for explicit instruction.
And I am thrilled to get to talk about this topic. You know, one of the things that often happens when I'm doing presentations on explicit instruction is people will say, can you give me more idea about the research, more idea about the research, more idea about the research on explicit instruction. So today we're going to talk about more research on explicit instruction and also just some really interesting things for us to attend to. And so let's get started right away. And I welcome all of you, particularly right before a holiday weekend. And I see that someone is from Hawaii, a good friend of mine, so some people are up very early in order to do this. So I greet all of you. It's a beautiful, though overcast day in Portland, Oregon. I get to be home for the weekend, and that is a treat. Well, one of the gifts that comes from Australia, where I'm off to in 2 weeks to do training on explicit instruction, and a TOT there and one in September there, is the work of John Hattie. And I know that you're familiar with John Hattie's first book, which reviewed more than 800 meta-analyses, sort of searching for the holy grail of instruction, what makes the most difference. And then he wrote a follow-up book for teachers, and then a follow-up book with a cognitive psychologist. And in that book, he does a summary of what he considered those variables they looked at where the teacher was an active initiator, an active person in terms of teaching, an active person in terms of giving feedback, very actively engaged, versus things where there was a teacher more as a facilitator. So this chart, found on page 73 of his third book, is fascinating for us and a very useful way to convey aspects of explicit instruction and their strong effect sizes. So let's just look at a few of these. First of all, in terms of effect sizes, if it is an effect size of 0.40, most statisticians in education would say that would be instructionally significant. If it is much lower than that, and there's even some that are negative, for example, retention has a negative effect size. Oh my goodness, we just don't want to go there. It doesn't have proven effectiveness. So looking down this, let's just look at some of the ones that directly parallel the research that is conveyed in the first chapter and throughout the rest of the chapters in explicit instruction. So starting with teacher clarity, effect size of 0.75. Clarity in instruction, clarity in directions, clarity in the actual wording of assignments so that students get it. And to me, this also includes one of the variables that we look at, breaking it down into obtainable pieces so it is clear. Some of the things that I've been recently reading about is the expert effect. I'll just tell you a little story. So I was flying from recently, well, spring vacation, from New York City to Portland, Oregon. And right next to me was a young woman who was a freshman in a high school in Portland, and her father. And she slept a few hours because it was going to be 6 hours, and then suddenly she woke up and decided, oh my goodness, I'm back to high school on Monday, I better study. And so we had some interesting conversations about her studying as I taught her retrieval practice and how to study those flashcards more effectively. But she conveyed to me that her classes were going well, all except one, and that was her algebra teacher. Her algebra teacher who was really an expert in math, and she had been advanced beyond, skipped one class as a freshman to be in Algebra 2, and he was just an expert. But she didn't understand it at all because he didn't break it down, didn't explain it. Now, the problem is, if you're a real expert in an area, as the research would show, many times you just don't walk any longer in the moccasins of a novice. You're not teaching as a teacher would, thinking about who you're teaching and what they have as background knowledge. And I think teacher clarity often is, even by expert teachers in their domain, occurs because they're not looking at it from the point of view of a novice. Of course, one of the things that we always stress in explicit instruction is I gain a response from you and it's followed by feedback. But look at that effect size, 0.74. And in terms of content, we often teach strategies. Strategies for figuring out and sounding out a word, strategies for taking notes, strategies for figuring out the main idea, strategies for writing a paragraph. And then direct instruction has a effect size of 0.59. Now, in Australia and New Zealand, where Hattie wrote his first book, and then he's now in Australia, direct instruction is used more as a global term, not just a specific one in terms of direct instruction materials. And so it's more in keeping with explicit instruction. And mastery learning, teaching things to mastery and then to automaticity, 0.57. Provided worked examples. Just a few weeks ago, a new IES, which we will talk about later, guide came out in algebra, and their first suggestion is, their first recommendation is you teach children how to use worked examples to guide you in solving other equations. And providing the goals is one of the things embedded in explicit instruction, high effect size. Getting frequent effects of testing. Well, basically that refers to retrieval practice, where I asked you questions where unaided you have to retrieve the information from memory, digging deeper neural pathways. So notice how many things are in the list as teacher as activator, which have effect sizes above 0.40. Then let's flip over to a teacher as facilitator. And particularly interesting to me, sort of head down to the bottom here of this chart, to problem-based learning, 0.15, where students have a problem and they are going to figure this out. You know, and I see problem-based learning taught in so many places, but not coupled with teaching kids information or strategies before they are doing it. Discovery method in math, 0.11. We're not going to have many mathematicians if we only use discovery, because obviously some children didn't. Same thing with whole language, 0.06, just slightly above breathing, is just not making a difference. And, you know, it's sort of, to me, unconscionable that we would use procedures that have no effect size that's going to make a difference. So this is, to me, an interesting little chart to look at. But today I'm actually going to focus on something a little bit different, and that is the IES, the Institute of Education Science Practice Guides, that come out of the What Works Clearinghouse. Now, I know that you may be familiar with some of them, but they really are a great resource. They pick a topic like early reading or adolescent comprehension or algebra. They bring in a group of practitioners and researchers in that area. They look at studies specifically on aspects. For example, the recent one on aspects of teaching algebra. And then they have criteria for utilizing the studies based on the actual quality of the research itself. And then they synthesize those results and share with us best practices. Now, to me, what's interesting about this is that it expands our vision of explicit instruction to let's look at what is proven effectiveness in early math? What is proven effectiveness in early comprehension? What is proven effectiveness in algebra? What is proven effectiveness in study skills? What comes to the top are all of those attributes that we have worked on in terms of explicit instruction. In fact, almost every single one of them has as their very first recommendation, teach. Yes, it appears that teaching helps in comprehension and in writing and in algebra and in study skills, and they often say explicitly teach it. So today I just picked out a few to convey how useful this information is and what a great source it is for us. I think I'm going to even do a longer webinar on each one of them just because of the critical nature of them. But let's just look at the ones that I chose for this webinar. So one is improving reading comprehension in kindergarten through third grade. And so again, they looked at all the research that they found, judged the worthiness of the studies, then synthesized them. So the first recommendation is teach students how to use reading comprehension strategies. Not have them discover it, not expose them, but teach it. Second recommendation is to teach them to identify and use the text organizational structure to comprehend, learn, and remember the content. So, for example, here they're talking about, and you can read more about it when you access these yourself, but they're talking about, for example, if it is narrative, that there is a setting, that there is a character, the character has a problem, the character tries to resolve it, and then there is an outcome, the structure of a narrative. Or if it is informational text, the structure of informational text might be the headings and the subheadings. That's one structure. Another structure might be cause and effect embedded in it or sequence embedded in it. And when students can identify those structures, they comprehend, learn, and remember more. And it says guide students through focused, high-quality discussion on the meaning of the text. So an aspect of active participation and high-quality discussion where the students have a question, they prepare for the discussion, they might share with their partner first before the discussion occurs, and it might even be scaffolded with things such as sentence starters and so that the students have a way to enter in a very appropriate way to the discussion. So I took number one, teach students how to use reading comprehension strategies, and selected a strategy to just model for you, just to remember what modeling would look like and explicit instruction would be for a strategy. So they talk about, in the recommendations, they augment it, expand on it, and they said, here are some examples of effective reading comprehension strategies that students, and read that with me as we go, students develop and attempt to answer questions about the important ideas in the text while reading, using words such as where or why to develop their questions. Now, we do know that if students can read something and develop a question and answer it, that this would definitely increase their comprehension. In fact, this recommendation had a very strong outcomes. Well, all of the recommendations did. And so I'm just going to model what it would look like if we were teaching it using I do it, we do it, you do it. So be my third graders. So we are going to be reading about a number of inventors, and today we're going to read about Thomas Edison. And so put your finger under the first word of the paragraph. I'm going to read. When I stop, you say the next word. So be ready. Thomas Alva Edison lit up the world with his invention of the electric light. Without him, the world might still be a dark place. However, the electric light was not his only invention. He also invented the phonograph, the motion picture camera, and over 1,200 other things. About every 2 weeks, Edison created something new. Be my third graders. So after I read that, one way I could really think about it is I could ask myself questions and answer them about what I just read. Now, let's look at the kind of words we might use. Who, what, where, when, why, how. Say those with me. Who, what, where, when, why, how. Now, I might ask myself a question such as, who is this about? I used who, and I would say the answer is, what, everyone? Right, Thomas Edison. I might say to myself, what did he invent? What did he invent? That would be a good question because this whole paragraph about Edison talked about what he invented. And so then I say my answer would be, what did he invent? Thomas Edison invented the electric light. He invented photograph. He invented the movie picture camera. He invented 1,200 things. So the thing that I really wanted to answer there is, what did he invent? Well, let's look at another paragraph, and this one we're going to do together. Now, teacher talk. You probably might want to model it again because that's not that easy. I said to myself, well, maybe we should start with fewer questions. But the whole point here is the discrimination of what is critical, thus which questioning words you would use. So you'd probably have to teach the use of the words through many I do it and we do it together. So back to being my students, and everybody read it. I'm going to read when I stop, say the next word. Thomas A. Edison was born in Ohio on February 11, 1847. His family moved to Fort Huron, Michigan, when he was 7 years old. Surprisingly, he attended school for only 2 months. His mother, a former teacher, taught him a few things, but Edison was mostly self-educated. His natural curiosity led him to start experimenting at a young age with electrical and mechanical items at home. Now, there's many questions that we could answer, and first of all, we could ask a question about where. And so think of a question that would go with where. I bet you had more than one question. You might have said where he was born. You might have said where he moved and lived most of his life. Or you might have said where he went to school, which was at home. So there were many where questions we could have asked. We could have also asked a when question. So think about a when question. And so you might have said when he was born. Now, we don't really expect you, third graders, to remember when he was born, but it is useful to note that he was born around 1850. Oh, Okay, I can sort of round it off and remember sort of the middle of 1800s. Oh, that's when Edison was born, in the middle of 1800s. Now, I could also ask a how question. So think of a how question. You tell your partner, talk to yourself. So then I call on someone, they might say, how did he get his schooling? Oh, that would be a great question. In fact, that would be a really important question from this. How did he get his schooling? He only went to school for a short time. His mother taught him some, but mostly he sort of educated himself. So we think about the paragraph and then what kind of questions we could ask about it. Now, this skill is such a useful one, but it would take a good deal of guidance. From here, I told them the question word, and they had to think of a question. But then what I would want to do is go to have them think, what questioning word should we use for the paragraph? But we'd still do it together until they could do it independently, where they could read and think of a question, share it with a partner and the answer, and then also we could call on individuals. So to me, this is one that's been research validated. It certainly would involve explicit instruction, not discovery, in order to be very good at it. But don't you wish all second and third graders were being taught exactly this strategy? Because they could use it independently. It goes back to the critical thing that we might do during reading, which is reflecting on it. But here it's teaching a systematic way to reflect on it by generating a question and a subsequent answer. Well, so explore more about the K-3 Comprehension Practice Guide. So I gave you more. Well, actually, you do it, but there's a lot more we do it before we ever get here. And I kind of got interested in Edison as I read this, and that's exactly what we want. We want children to understand it and be curious and want to learn more about him. Well, let's look at the next one that I chose. This is the Teaching Math to Young Children. And so the first recommendations, 1 and 2, again, employ explicit instruction. So it says teach number and operations using a developmental progression. And then recommendation 2, teach geometry, patterns, measurement, data analysis using a developmental progression. Now, if you have never checked out this practice guide, one of the real richness of it are the developmental progressions. And the way they wrote them in terms of a sequence and saying when the students reach this milestone, then go to this, and when they reach that milestone, go to this, and when they reach that milestone, go to this. And so they're really looking at the sequential nature of math, but also the need to teach operations and numbers and vocabulary, all embedded in these recommendations. And then their third one, and there's more, I just picked out the first recommendations here, which all involve teaching. And it was use practice monitoring to ensure that the students' math skills are building. Of course, we want to use data to make decisions, particularly in relationship to response to intervention. Do we need intervention tier 2 or tier 3? So let's just look at just a little bit of this. And it looks like you're going to have to get the teacher's manual, well, the practice guide to get it. But what they do is they list a skill, and then they say the child is ready for the next step when, and they're able to do this. And then they look at the next thing that would be meaningful to teach, and then they talk about when they could go to the next step. And so there is a developmental progression, in this case, for number knowledge and one for operations that is very sequential. And so let's just look at one. And so I looked at the numbers, and it talks about sequentially teaching kids to use one-on-one correspondence and be able to count to 4. And boy, it's been a long time since I taught this, so here we have some objects, and we're going to model it. So I touch each of these and I say, watch me count these. I touch and I count, and 1, 2, 3, 4. Listen to me do it again. 1, 2, 3, 4. And remember that variety in terms of practice. And so I say, all right, watch me touch each object and count. 1, 2, 3, 4. And then watch me count one more time. I touch each one. 1, 2, 3, 4. And then let's do it together and touch your smiley faces. Those are smiley faces. You might not recognize that. Where is smile? Okay, those are buttons now. And count them, everyone. 1, 2, 3, 4. Just do that again. Touch and count, everyone. 1, 2, 3, 4. And we would continue doing this. And it is particularly difficult to get these students to touch each object. So you might even have to have them move them and line them up so that they're more accurate. 1, 2, 3, 4. And so we're going to continue that many, many times. And we're going to include some variety that don't go to 4 because if they all go to 4, then they are going to go 1, 2, 3, 4. And they're not going to say 1, 2, 3 and stop there. So we have to have variety, we have to have examples, we have to have non-examples. And count it together, 1, 2, 3, 4. I actually just had fun making the slides. Now you do it. So at the very beginning of math learning, you know, we can't just pray and hope that students are going to discover something as important as one-to-one correspondence. So we use I do it, we do it, you do it. Well, let's go to a little bit of higher level. And so this is the Adolescent Literacy, Effective Classroom and Intervention Practices. About one that totally reinforces the use of explicit instruction. So their first recommendation is for adolescents in literacy, provide explicit vocabulary instruction. All right. Maybe even do things such as pre-teach vocabulary to prepare them for comprehension of the passages, some front-loading, teaching them very systematically vocabulary within different domains. And their second one, provide direct and explicit comprehension strategy instruction. Again, when you look at the practice guide, it's going to list all of the studies that met their criteria from which they could make this conclusion to provide direct and explicit comprehension strategy instruction. And then their third recommendation is provide opportunities for discussion of text meaning and interpretation. So that very much parallels what they recommended in the IES practice guide for the primary K through third grade. So when we look at this, we certainly, both in the explicit instruction book as well as in all of our trainings, have focused on both of these, explicit vocabulary instruction and direct and explicit comprehension instruction. So let's look at both of those, just as a reminder of what we know, but also that we have a research base that we can come back to that strengthens even more what we know about those two areas. So The first recommendation was provide explicit vocabulary instruction. And the routine that we garnered from looking at the research on vocabulary instruction, one taught in the book but also taught in our trainings, is we would first introduce the word, that we would introduce the word's meaning, and that we would then illustrate it with examples and, in some cases, non-examples. And then we'd ask questions to check understanding. So one of the emails I received was, could you give us more examples that come from middle school and high school content area classes? So I could have picked many social studies examples. I've taught suffrage lately. I taught science, potential and kinetic energy, but I picked one entirely different day that I was teaching in a high school art class. And so the first thing we do is we introduce the word and its meaning. So you're going to be my students. So looking at me, so today our term that we need to use and understand in order to be able to do drawings and paintings on two-dimensional paper is the concept of linear perspective. So everybody, what is the concept? It is linear perspective. Put your hand on the table, and for linear, slow it down and say the parts of the word out loud and go. Lin-e-er. One more time, lin-e-er. And say the whole word, linear. And the second word, perspective. Slow it down and say the parts, perspective. Say it fast, perspective. That's just a reminder about how important it is that we ensure that the students can say the word, that they can pronounce it correctly. Something that many content area teachers sort of just whoosh through. But if you cannot pronounce linear perspective and say it as a totality, linear perspective, you're not going to attach meaning to it. You're not going to be able to store that cognitively and retrieve it. So we want to be certain that the students can pronounce it. So after we've introduced the vocabulary word or term, then we introduce its meaning. And we might use a sentence, student-friendly explanation, but in many content area classes, we might want to use the definition given, break it down into its critical attributes. So this is taken right from their book. But I have to be careful because there are some words that they might be unfamiliar with. So back to being my high school students. So here I have broken down the definition for linear perspective. First, it has to do with, what everyone? Parallel lines. Put your hands together so that your hands are parallel. So equal distance from each other. So it has to do with parallel lines. And if we were to look at parallel lines in the distance, they would recede in the distance. They would recede in the distance and read the third attribute. Appear to get closer together and converge, come together. So they recede in the distance. They appear to get closer together and converge, come together. And it creates an illusion of what, everyone? Depth and distance. So if I am a painter and I want to show depth and distance, but all I have is a two-dimensional piece of paper with width and length, but no depth, I'm going to use what? Linear perspective. Okay? So let's just review here. It's about parallel lines, and we want to show depth and distance. And if we were to look at it, it would recede in the distance, appear to get closer together, and converge. Well, let's look at some examples. So after we've presented the concept and the meaning of it, this case by going over the critical attributes, then we would want to give examples. So back to being high school students. So here we have a perfect example of linear perspective on a two-dimensional piece of paper. This is a photograph. And the photograph is showing lines that are railroad tracks. Now, of course, the railroad tracks, if we were right at a certain spot, would be parallel, equal distance. But when we look at it, we see that we have those parallel lines, and they recede in the distance. They appear to get closer and closer together, even converge, come together. So that's a perfect example of what, everyone? Linear perspective. And then we check their understanding. So now I want you to carefully examine this drawing, and you're going to ask yourself, how did this artist show linear perspective, the illusion of depth and distance? So look at it carefully, because you're going to explain it to your partner. So how did this artist use linear perspective to show depth and distance? And you might have to talk to yourself. So one, you are going to tell your partner how this artist used linear perspective to show depth and distance. And as you explain it to your partner, I want you to actually use gestures, because the gestures will make us think more concretely about this definition. So start by saying, this artist used linear perspective by, okay? Talk it over with your partner and go. So the students would explain it to their partner that if we looked at the the sidewalks on the road, they are parallel, but to show it, they have two lines that recede in the distance and get closer together and converge, thus showing us there is a distance here. You might have talked about the lines of the windows, the lines of the building tops. So we introduced the word, working on the pronunciation. We introduced the meaning by bulleting out the critical attributes, and then we illustrate it with examples, and then we begin to check students' understanding by having them examine, in this case, a picture, and being able to explain the concept of linear perspective. Okay, and more linear perspective, checking for understanding. See, what I love about this is that, first of all, the IAS practice guide says provide explicit vocabulary instruction. But it's not just in our math class and our science and our social studies class. It's in our art class. And in all of those classes, students can expand their vocabulary. But we're not just going to hope for it. We're not just going to have them discover it. We're going to give them some explicit information on it to enrich them. Well, let's look at another example. And I just want you to see how much explicit instruction is reinforced in the practice guides, even though they come in from very different domains. So their second recommendation is that you provide direct and explicit comprehension strategy instruction. I'm just going to read a little bit of this, and it's like reading out of an explicit instruction book. Use direct and explicit instruction for teaching students how to use comprehension strategies. As the lesson begins, it's important for teachers to tell students specifically what strategies they're going to learn. Tell them why it is important for them to learn the strategies. Model how to use the strategies by thinking aloud with the text. Provide guided practice with feedback so students have opportunities to practice using the strategies. Provide independent practice using the strategies and discuss with the students when and where they should apply the strategies when they read, and the importance of having the will to use the strategies along with the skill. I mean, it's like a summary of what we know about explicit instruction, but it's so beautiful to have other sources so clearly articulate, because this is exactly what we do. We tell kids what we're going to teach them. We tell them the relevance of it. We model it by thinking out loud. We provide guided practice of the strategy. We also then lead to independent practice of it, and then discuss when and where they might use it. Beautiful. I love it. And so I know that many of you have utilized with students the original research by Lynn and Doug Fuchs and Pat Mathis on paragraph shrinking. But I thought today that it would be useful for me to share the utilization of a parallel strategy by Sharon Vaughn's group out of collaborative strategic reading called Getting the Gist. And they simply have the same big idea, searching for the main idea, but Getting the Gist is written for older students. Okay, so if I was teaching this, remember that I am supposed to tell the kids what the strategy is and why it's important for them to use this strategy and then to model it. So be my middle school students. So we are going to be using a strategy in our social studies class called Getting the Gist. Getting the big idea, getting the main idea, getting the gist. And so what's it called? Getting the gist. And when we read social studies, many times what we really want to do is take a paragraph and shrink it down to the most important understanding, the main idea. And we might even write that down as a way of taking notes in social studies. And that's exactly what we're going to do. When the most important thing is not the details, but the big idea, then this strategy is perfect. So let's just go over the strategy first, and then I will model it for you. So the first step is to name the who or what the paragraph is about in a brief phrase. So the first thing I'm going to ask you to do, or your partner will ask you to do, is name the who or what the paragraph is about. And step 2, read it with me, identify 2 or 3 important details about the topic. So I ask myself, what are 2 or 3 important things that I might want to remember about the who or what? And then we're going to take that and put it together and do the third step, shrink the paragraph by stating or writing the main idea, which we're mostly going to write it down so that we can have a summary, a beautiful summary of what we have read. Now, shrink it means that you're going to write 10 to 15 words, not over 15, 10 or 15. Well, we're going to start today with one of our studies in geography. We've been looking at different African nations, and we're going to look today at Kenya. So then I'd stop and show them on the map where Kenya is and talk a little bit about it before we went on to model it. So here is our first paragraph about Kenya. And everybody, I'm going to read. When I stop, say the next word. The Republic of Kenya is a country in East Africa. Ethiopia borders Kenya to the north. Kenya is bordered by Somalia to the northeast, Tanzania to the south, and Uganda to the west. On the southeast is the Indian Ocean. So the first thing I have to do is read the paragraph. Now I have to name who or what this paragraph is about. So I say to myself, well, the whole paragraph is about Kenya, but it appears that it is, because I can use a phrase here, is talking about the location of Kenya. Oh, no, I see the borders, what surrounds Kenya. So this paragraph is about the borders of Kenya. Oh, Now, the next thing is to identify 2 or 3 important details. Now, there are lots of details here. So they say what is to the north and what is to the south and what is to the northeast and what is to the west and what is to the southeast. So sometimes you need to, if you're going to shrink it, look for a category. For example, I say to myself, I'm not going to be able to shrink it down and give the name of all of the bordering countries. Instead, I might just say that it's bordered by 4 African countries, down to one idea. Okay, so it's talking about the borders around Kenya, that's the who or what, and one detail is there are 4 other countries that border Kenya. Also, one border is the Indian Ocean. So then I want to do the last thing is shrink it. Now that means the who and what and the important details. So you count for me. See if I can do this in 10 to 15 words. Kenya is bordered by 4 African countries and the Indian Ocean. All right. So, and I'm going to write that down. Now, when I was thinking about this before, mine was somewhat close, so go down to the bottom and read it with me. Kenyan, an East African country, is surrounded by 4 African countries and the Indian Ocean. See, now, that shrunk it down and helps me remember it. Teacher talk. You might have to model it more than one time, and particularly with older kids because there's so many details and you really have got to model by thinking out loud how to reduce it down and what is important. So it may take additional modeling. And so in this paragraph, let's just read through it, and it's a perfect example of, oh my goodness, how to get it down to a who or what and just a few critical details. So part of their history was a time of problems. At some times, other countries attacked to take over the country. There was much fighting. Kenya was made a British colony. That meant that Kenyans did not rule their own land. The native people of Kenya believed in independence. They did not want to be a colony. It took years, but they got their land back. Kenya became independent in 1963, and the Kenyan people declared not only their independence, but formed a country. They took the name Kenya as the name of their country. So I again start by asking myself the who or what. So this is really talking again about Kenya, but it's actually talking about Kenya's history. Okay, Kenya's history. And then I have to name 2 or 3 important details. Okay, let's see. One important detail was that they were a British colony ruled by Great Britain. Okay, that's really important. And they sought independence and gained independence. And this occurred in 1963. Now, usually, many times in our work in social studies, I wouldn't need to have you remember the exact date. And here, knowing the date, 1963, is only important because look at how recent Kenya became an independent nation. And so, I mean, that's just not many years ago. And so it's still very, very recent. So they're still learning how to become an independent country. So I say to myself, when I shrink it, let's see, you're again going to count. Kenya was a British empire, but in 1963, it became an independent country. And so when I wrote this down, I wrote, and read it with me, Kenya, once a British colony, became an independent country in 1963. Can you see how thinking out loud is so critical in teaching this strategy? But boy, is it a powerful one, particularly for social studies and health classes, not so much for science because there the details really matter, and so other strategies have to be used there. But we're not just reading it and say do it, we're really teaching the strategies and guiding the students through thinking about it where they have to read the paragraph, name the who or what, then think of 3 critical details, sharing with their partner, and you call on individuals, and then shrinking it by writing down a sentence that includes the who or what and the important details, and reading it to their partner, and then having individuals read it. So we're probably going to do a great deal of guided practice, particularly given the complexity of some science and social studies textbooks. We can continue. So when I shrunk this paragraph down, it talks about the fact that it was not one country when it became a colony. It had many different groups, many different tribes with their own language, their own cultures, their own histories, and this continues to create great chaos in Kenya. And so down to different groups with different languages, cultures, and histories cause problems in Kenya, which they're going to read more about. So the big idea here is, though, it is direct and explicit comprehension strategy. A strategy, once we've taught it, though, we can use it again and again and again and have beautiful summaries in our social studies classes. Well, I've got to watch my time here because I don't want to leave out the newest practice guide. And this came out just a few weeks ago in April. And their first recommendation is that you would use problems to engage in analyzing algebraic reasoning and strategies called worked problems. Number 1 recommendation. And then teach the structure of algebraic representation. Then teach the kids intentionally how to choose which algebraic strategy to use for solving a problem. Oh, I just love to see teach, 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 because that is what explicit instruction is about. But let's go to the first one, because just this last week, I had a little goddaughter at my house who's learning algebra, and she is just the very beginning. She's a 7th grader, and she is confused and is not getting it. And so this is exactly what I taught her, is let's look at worked problems, let's show the work, and use our reasoning to figure it out. So if you look in this, you're going to find this one explained here, and they have a worked problem there. It says, analyzing and discussing solved problems can also help students develop a deeper understanding of the logical processes used to solve algebraic problems. Discuss and the use of incomplete or incorrect solved problems can encourage students to think critically. So, wouldn't you know, this problem, I said to myself, oh my goodness, I'm going to have to really think about. And so here is actually the work that they showed there, and I'm going to show you the kind of thinking that I had to do. So first of all, I've got to get this so you can see it and I can see it too. The problem was an exponent problem. 3 with an exponent of 4x plus 3 equals 81. And I'm going to use the worked problem to figure out the logic of how you solve this. I'm to figure out x, which would indicate the exponent, the number of times that the number is multiplied. And the first thing that they have shows me 3 with an exponent of 4x plus 3 equals 81. And the next step is they have the 3 with the exponent of 4x plus 3 equals 3 to the 4th power. I see what they're doing here. They're taking 81 and showing it how many times it would be multiplied 4 times in order to get 81. So I wrote it down. You have to explain it to yourself. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Oh, I get it. So to make this so both of these had an exponent of 4, they changed this into that exponent. All right, I get it. So here we have 3 to the exponent 4x plus 3 and 3 to the exponent 4. How cool. The next thing they show is 4x plus 3 equals 4. How did they get that? They must have divided each of these, both sides, by 3. I divide each by 3, then I don't alter the equivalency here. And so that would get rid of this 3 and this 3. And so then we end up with 4x plus 3 equals 4. All right. Next they had 4x equals 1. Now how did they get that? Oh, I see. They had to subtract 3 from this side and 3 from this side in order to get it. 4x equals 1. Next they show x equals 1/4. And so that means that I see they divided this side by 4 and this side by 4 to get x equals 1/4. Wow. Through that logical thinking, I have an idea how to do other problems that might be somewhat parallel. Don't you wish your algebra teacher had showed you the logic of using worked problems? This is a powerful way to assist our students in algebra. Well, my goodness, I had really a lot of fun today looking at these practice guides and seeing immediately that they really reinforce everything that we talk about in explicit instruction. I want to go a step further. If you had listened into the last 2 of the webinars, they were on practice. And so the practice guide called Organizing Instruction and Study to Improve Student Learning. How to organize instruction and study to improve student learning. Recommendation number 1, spaced learning over time. Oh my goodness, there it is. That's spaced distributed practice. Recommendation number 2, interleave worked example solutions and problem-solving exercises. Oh, that varied practice. Use quizzing to promote learning. Retrieval practice. So the real message here is that explicit instruction has been reinforced, and the attributes that we emphasize in explicit instruction have been ones that have been found true in reading comprehension, in algebra, in math instruction, because the practice guides look at specific domains. Well, it's going to be a holiday weekend coming up. Now you have time to go online and download all of the practice guides, or have a really good time. And may all of you have a great summer holiday. We're going to be back in August. If you have a topic that you're just dying to have covered, you let me know. I so appreciate your time, so appreciate your passion to ensure that all children learn. And explicit instruction is one of those big tools to make that happen. Thanks so much.
Anita, thanks so much for taking the time today to present another webinar. Looks like I have just one question that came in, and Anne wanted to know if you could help with a clear and easy explanation for the difference between a skill and a strategy.
Okay, hi Anne Watanabe. A skill and a strategy. A strategy is usually looked at as a multi-step practice that you would use. So certainly when we look at being able to use getting the gist, namely tell the most important thing and say it in 10 to 15 words and write it down. So that are a number of steps that I'm going to use in order to do something. A skill is generally one behavior, such as I might have a skill, I write the letter T, versus multi-steps. But Anne, in the end, they're both how to do something. Whether I have a skill, how to do it, or a strategy to do it, they both focus on how to do it versus factual knowledge versus vocabulary and concepts.
Fantastic. If anybody else has any questions, this is a great time to drop them in the Q&A box, and then we can answer them in the next minute or two before we wrap up. Otherwise, you can always email them to us, and we can make sure they get to Anita. We, again, appreciate all of you joining us today. We will send out the recording link probably early Monday, along with an updated version of the handouts. And then, as Anita noted, our next webinar is a ways out. We'll be back Friday, August 7th at 10 a.m., and we'll send you an email and get you a heads up on that since it is a little bit of a ways out. Again, we really appreciate all of you taking the time to come on out and watch the webinar live. And, of course, you can always follow up and share the recording with your associates.
It was a treat. Thank you so much. Have a great weekend.